Hello everybody, welcome to my screencast tutorial on noise, parentheses. Today we're going to be exploring the noise function in processing, to be specific processing 2.2.1, but this is applicable to other versions as well. Now noise may seem quite complicated, but in reality, I'm not going to lie, it's pretty complicated, but we're going to give learning it a go. So the noise function in processing is based off of something known as Perlin noise, which was developed by Kevin Perlin in 1983 and has a plethora of uses in modern technology. Ever played a game that has massive landscapes with semi-repetitive textures? I'd bet my mouse that it was generated using Perlin noise. While the most common use of Perlin noise is in texture generation, it's also frequently used in audio. It can also be used to generate realistic fires and smoke, which is why where I got some of the inspiration for our project today. So, I created this small sketch here, okay? And it's a pretty small sketch. If we just look at it, we have some variables being defined, a for statement. It's pretty simple, just basic setup and draw. We're going to go through it bit by bit. So here we have a variable being defined, which is the noise scale, and I'm going to talk about that a little bit more later. We just have our setup, which is being a 600 by 600 box, and if I run this really quick, you're going to see what's actually happening. So here we're generating a waveform of sorts that almost looks like a natural landscape. Think of these as mountains almost, right? Kind of looks like a mountain range, and that's because Perlin noise generates natural sorts of landscapes and such. So that's what's happening, just a simple 600 by 600 box. We have our draw, we're drawing our background. If we get rid of our background, then we're going to run into some issues. Where it's not actually drawing properly and they can't overwrite each other, and we have some troubles. So we just redraw our background each frame, and then everything's fine and dandy. Then we go to our noise detail. Now the noise detail is effectively your resolution. So if we go down to something like 2, it's going to be very low resolution. That means that we're going to have much smoother transitions between things. So it looks very like, it looks more like waves almost in a sense versus mountains or like hills or something. And that's because it's much smoother because we turn down the noise detail. But if we turn it up to something like 20, it's going to be very, very sharp. And you see we have a lot more differentiation between all the pixels, and that's just because it's much higher definition versus it just trying to have a smoothing effect on all of them. So we're going to go to 8. And here we go. This is back to what we were doing before. So here we have our for statement and what this, whoops, oh boy. Here we go. We have our for statement, and what we're doing here is we're just going through and drawing each line, and in here we are drawing each line 600 times. So this is going to be drawing in here. Each part of this waveform is an individual line, so there are 600 lines being drawn each frame, and they're all dependent on everything in here. So what we're doing is each time that we draw this, we're making a new noise value, and the noise value is a noise function which is dependent on mouse x plus x times the noise scale. So the noise scale is up here, and what we're doing with the noise scale is that's going to drastically affect our noise function, which is determining how different all of these are going to be from each other, all of these lines. So if we change our noise scale to something really large like 2, we're going to have huge jumps. You see almost every single pixel is drastically different from the other. But if we go back to something a bit more normal, like 0.0002, it's going to be very slight changes. And I see there's just very slight bumps. But if we just go back to 0.02, it'll look like it was before. So if you go with a very small noise scale, then you're going to have issues. If you go to a very large one, then you're also going to have some issues. So we're just going to stick around here. You can modify that a little bit, but this is just somewhere that seems to be pretty good. With our stroke, it's pretty basic. We're just making white, and if we change this to like this, then we're just going to have red. You can see here we're just making red. But it's a bit of an eyesore, so we're just going to go back to the white. And here we go, we're just running it white again. Now what we're doing is, so we're drawing, this is within the for statement, right? We're drawing each line 600 times. So these lines are going to have their starting points. So this is the starting point, and then our ending point. Okay, these have 2 points. So the first point is the x is going to be the x, and that's because it's going through 600 times and drawing the x and adding to 1, so it's going to be x is equal to 1, x is equal to 2, x is equal to 3, and it's going to keep going like that. And then for our y, we're taking the mouse y plus the noise value times 80. So if we change that to not even being multiplied by 80, it's going to be flat. It's going to be almost completely flat with some very small dips on occasion, but it's not going to be anything like we were seeing before. because the noise is having very, very minimal effect, and if it's going to have any effect at all, it has to be a really big noise value. So we go back and we do times 80. Now we can include that somewhere else as well, but we'd have to up the number because it wouldn't be multiplying the noise value as well. So here we have what it normally looks like, and then when we're drawing the bottom point of our lines, it's going to be the x again, right, because it's going through and adding the x each time, and then the height, and the height is just going to be the bottom of the frame, so it's down here, right, it's going to be down here. And then we could actually change it. What looks kind of cool is if we change this to height divided by 2. And then it kind of folds in on itself. You can generate some pretty cool looking stuff that way. But yeah, so that's basically Perlin noise, and I hope that you had as much fun watching this and learning about it as I did making it for you guys. So, thanks for watching.